Okay, so continuing the notes, we're on concept 4, Pythagorean theorem. Okay, so for this one, we're just going to find our missing side, and we already did that before in the previous notes. So remember, this is a squared plus b squared equals c squared. They label a, b, and c for us, so I'm just going to plug in my numbers. So I have 5 squared plus b squared, because I don't know b squared, is equal to 13 squared. Okay. So the reason why it's bringing in Pythagorean theorem again is because we're talking about squares and square roots. So you know that 5 squared is 25 plus b squared. And 13 squared? 169. And then to solve for b squared, what would we do? Subtract 25. And so we have b squared is equal to 144. Okay, now what? Take the square root. And so b is equal to 12. And then what's the units? Feet. Okay, so remember before I said technically this is equal to plus or minus 12. But why did we not include negative 12?
Because since it's even, you would put the absolute value and ends up taking off the negative or any negative.
Oh, good. I wasn't even thinking of that. But yes, since it's even, we would do the absolute value. That would take off the negative. But there's one other reason. You can't have negative feet, right? Because we're in a real world problem. You can't have negative feet.
I'm sorry, where did you get the negative from?
No, like in a hypothetical situation where it's negative, even if it's
Yes, I
just square root.
So I was saying, like, really, this is plus or minus 12 when we take the square root. But in this case, since it's an application problem, we can't have negative 12 feet. And then also, like he was saying, okay, well, this is even, which means we would do the absolute value. The absolute value of negative 12 is positive 12. Okay. More Pythagorean theorem. It says 2 boats leave the dock at noon. One travels due north at 6 miles per hour and the other travels due east at 8 miles per hour. How far apart are the 2 boats after 2 hours? So this word problem here is just there to distract you because they gave you an image. Okay, and they already filled in all the units, so we're just going to do the same thing and do a squared plus b squared equals c squared. Okay, so I have 12 squared plus 16 squared equals c squared. So what is 12 squared? 144. 16 squared? 256 equals to c squared. So we add those numbers together, and then we get what value? 400. And then how do we get c by itself? Squared or square roots? Square roots. So c is equal to 20. Right? And what would be the units? Miles. So the question was, how far apart are the 2 boats after 2 hours? Well, the boats are 20 miles apart after 2 hours. Because we just answered this, C. Okay, so I would say, yes, these applications are useful, but you're not going to be tested on this. You're going to be tested more on what we just did up here. Okay, so being able to simplify these radicals. Another thing would be the last part, and that's radical functions, and most specifically is how to find restrictions. Okay, so first we have to define what a radical function is. So radical function is f of x is equal to the nth root of x. So that could be the square root, the cube root, the fourth root, etc. Okay. So to determine what the domain is, we look at what n is. So if n is odd, okay, then the function's domain is restricted. And what that means by restricted is there's going to be a value there that is going to cause us to have no solution. So for example, if we had a square root, could we take the square root of a negative 5? No, which means the restriction on that square root would be that negative 5. We can't have that negative 5 inside of there. Okay. Then it says if n is even, the function's domain is all real numbers. Okay, or you can do the fancy R. So for these examples, we're first going to see if n is even or odd. Okay. So yes, looking at this one, it's even. So since it's even, what's the domain? No. Go back up. It's going to be, what word did we write? Restricted, right? In order to find out what the restriction is, we know that this radical cannot, yes?
So it's right here, if n is odd, the function is restricted.
Okay. I mixed them up.
Oh, I used Sharpie.
Oh, I'm so sorry. You know what you can do though? You can just go like this, right? That arrow, do that. Why are you writing in Sharpie in a math class?
It makes the notes look pretty.
I agree.
I got free copies,
No, that was my bad because I have my key from a few years back and I forgot that I retyped this up and so I changed the order, which why did I do that? I don't know. So yes, if n is even, the domain is restricted. If n is odd, then it's all real numbers. So that's my bad. I apologize. So now that we know the correct way, if it's even, we know that it's going to be restricted. And restricted means, so I'm just going to write what that means off to the side. Our radical can't be negative. So when we solve this, we are going to solve this and see when t minus 4 will be positive. Okay, greater than or equal to 0 means positive values like 1, 2, 3, etc. Okay, so then we're just going to solve this like we did in the very first notes when we talked about inequalities. So we're going to add 4 to both sides. And this means that t, the variable of the problem, is restricted to only numbers bigger than 4. That is the domain. So if we picked a number smaller than 4, we would end up with a negative inside of that radical, which would give us no solution, and we want to avoid no solution. Okay. So then we look at this one, and then looking at our n value, is that even or odd? Odd. So now that we know it's odd, then we know the domain is all real numbers. That's our answer. We don't have to do anything further. Okay. Okay, so here we don't see an n value, but we can assume it's 2. And is this even or odd? Even, which means the domain is going to have a restriction. So we're going to take what is under the radical. So that's only 3 minus 5x. Okay, only the part under the radical. And we are going to use what inequality after?
Greater than.
Greater than or equal to 0, right? Because we want everything in that radical to be positive, and that's why we write greater than or equal to 0. Okay, so then we just solve for x. So I'm going to subtract 3, and then I have negative 5x is greater than or equal to negative 3. And what would be my last step? Divide by negative 5. And then remember from those first notes, what happens when we divide by a negative number? It flips. So x is now less than or equal to 3/5. Right, because we had a negative divided by a negative, which gave us a positive.
So the 2 on the outside, it really doesn't matter.
No, because it's not under the radical. So if you want, you can cross it out. We don't care about it.
Like, I don't understand what you meant by that. Oh, it's less than x is less than or equal
Do you got it now?
to.
Yes,
Wait,
okay.
Always include that sign.
Always, because we never want our radical to be negative.
No, I didn't understand what you meant by flip. What you meant by
Is it flipping because
Oh, well,
it's-
this part, right? Because it went from greater than to less than, so the inequality flipped.
Why is it does it flip? Because when you divide by a negative,
Yes. Mm-hmm.
the inequality drops down, it's isolated, it's x. So it wouldn't be
Mhm.
x is greater than 3/5 because the initial problem is 3 minus x5. 3
Mm-hmm.
minus 5x is greater
Mhm.
than 0, right?
Yes. Yes. So what this means is, and we can test this by checking numbers smaller than 3/5. So for example, if I check 0, 0 is smaller than 3/5, and I plug 0 into this x value right here, 5 times 0 would be 0, and 3 minus 0 is 3, and is 3 positive or negative? Positive, so we know it works. But if we pick something, let's say bigger than 3/5, let's try 1. Yeah, 1. We would do 3 minus 5 times 1, which is 3 minus 5, which is negative 2. Okay, so that's why this is not flipped the other way, because if we picked numbers bigger than 3/5, right, which is a number like 1, we would get a negative under the radical, which is no solution. This is a very important concept. This will be on the test. Being able to do domain. I know, I'm sorry. Inequalities are back. Was that our last one? Yep.
Yes.